Okay, I'm going to give my Osage orange thumb sling a try with a ironweed stalk on some cottonwood. Got some smoke. Ember on. There we go. It's pretty cold out here today. I really got to go at it hard to get it to ignite and stay lit. This ironweed has an interesting aroma to it as well. It smells almost like incense. All right. Whee! You can see from the flames that it's a little bit blustery today. Worked great, but it's a little cold, it's a little windy, so I think we'll move inside to talk a little bit more. Back in a minute. So I've been refining and experimenting with my thumb sling assistant over the past few weeks, and I think I've pretty much perfected it, and I thought I'd share some of the details with you. I've experimented some with traditional thumb slings that kind of, you would maybe take a hand drill spindle and put a notch in the top and lay it over the top like that. Maybe you would whip it to the end of the spindle or something. I've experimented and have had not very good success with the traditional thumb sling type methods. The cords, I think, work best if they're rather thin, but those thin cords tend to eat into my thumb and cause blisters, and it's just really very uncomfortable to me. Plus, when the cord is sitting across the top of the spindle, once it rotates about 90 degrees or so, it starts working against you. And then really you only get about 180 degrees rotation. You don't get a lot of rotation in my experience using a traditional thumb sling, and it hurts my thumb. So I've experimented with this, I played with this, I didn't have a whole lot of success, thought I could come up with something better. And my first prototype, I've actually thrown away. It was really quite awful. I had a 1/2-inch PVC cap and about a maybe 2-inch piece of PVC tubing that I glued into it, and I glued a penny up into the top sort of as a bearing block. I thought it would be neat if I had a long tube to sort of keep the spindle straight with, but it turns out that I got a tremendous amount of side friction. It was really an awful idea. I threw it away. My next idea was just to use just the 1/2-inch PVC cap, and I've got a little piece of tubing glued inside of it, and at the top of my 1/2-inch cap, what I did was I took a penny and laid it into one of my sockets, kind of like that, and took a ball bearing and squashed it and made a sort of a bowl-shaped penny, and I glued that into the interior of my little cap. This worked really great. In fact, I've got another little short video on this 1/2-inch cap that I made earlier. This inspired me to keep trying. My next iteration was a slightly larger 3/4-inch PVC cap, and I glued a short piece of tubing up in it as well. But instead of a penny, I took a bigger socket and a quarter and a larger ball bearing, hooked that up into my bench vise, and squashed it into a cone-shaped quarter. This one, surprisingly enough, didn't work nearly as well as the 1/2-inch version, and the problem was there was a sharp edge right in here that was biting into the stalk. These caps will naturally kind of tip over a little bit like that, and that sharp edge was biting into the stalk and keeping it from rotating, or keeping the stalk from rotating inside of the cap. So what I did was I took out my Dremel tool and I radiused the interior, or this inside edge, and I reduced the friction, and the spindle rotates much more freely. So this continued my inspiration, and I ended up with my wooden one, and I'll tell you more about that one in a minute. But after I got my wooden one working really well, my son, who has a 3D printer, designed using his CAD software and printed me a 3D printed version out of ABS plastic, 100% infill. And I've got a really nice radiused edge on the inside here. It's radiused up in the socket. Really low friction, works great. The only downside is you've got to have a computer and the software and the experience to use it, and you've got to have a 3D printer, and it takes 5 hours to print this device with 100% infill. Well, after all of that, I decided I needed to make one out of found materials, and I made this one out of Osage orange, a piece of Osage orange. 3/4-inch hole, a good radiused interior edge. The overall height, I think, is about 1¼ inches, and it's about 1½ inches wide. I'll make some better measurements in a little while. To keep from getting blisters on my thumb, I've got some suede leather slings. They're about 3/4 inch wide and shaped to fit my thumbs. My cordage here is reverse wrapped artificial sinew. It's about 4 inches from the bottom of the cap to the top of the sling. The more I use this, the more it polishes up the insides, and the slicker it gets, and the easier and more efficient this has become. And what happens is, maybe in the video you saw a minute ago, you'll see that the cap will rotate a bit like this, back and forth, back and forth. But because of the interior of this cap is so slick, the spindle will continue to spin as I continue to roll it in my hands. In fact, with this device, I can get almost as much rotation with this cap as I can without it, just doing barehanded hand drilling. So the more I use it, the slicker this one gets. So this guy has been a real game changer for me. It's allowed me to make embers faster, more efficiently. If I'm tired, it gives me a hand. If I'm starting off with a brand new spindle and a new divot and a fireboard, sometimes I find it difficult to get a good burn in. This thing helps me get a burn in real fast. Anyhow, it's been a lot of fun. I think I've just about perfected it. I'm going to do some more experimenting and see what else I can do with it. I encourage you to give it a try. I think what I want to do now is do a little experiment and see what kind of downward force advantage I get with my thumb sling assistant. All right, stay tuned. We'll be back in a while. So now I want to see if I can collect some data and examine the relative force enhancement my Osage orange thumb sling device affords me when I'm doing my hand drilling. This is my wife's kitchen scale, and it's capable of reading up to 10 pounds. But some preliminary experiments show that with the thumb sling, I can actually apply more than 10 pounds of downward force. So what I did was I put my fireboard, so to speak, mounted equally between some support pieces of wood over here, support pedestal on my left-hand side, and the scale over here on my right-hand side. That will serve to divide the force equally between the two balance points, and so the readings that we get here on the kitchen scale will ultimately have to multiply by 2. My fireboard is not really a fireboard, it's just a piece of ash. My goal is not to make an ember, and I don't want to wear through the divot. I want to keep the conditions the same for all 3 stages of my little experiment. So this is just a little notch that I carved in with a knife, piece of ash, duct taped to a pine 1x2, mounted between my 10-pound kitchen scale and just some spare lumber from the basement. So let's get it turned on. And I've adjusted the kitchen scale so that the readout is in pounds. So I'm going to do this 3 different times. The first time I'm just going to do some floating and get some measurements on the downward force I'm able to apply. And then I'll do some fast passing and see what kind of downward force I can apply. And then I'll put my thumb sling on and see what I can do. All right, let's start with some floating. And by the way, I should mention I'm in a slightly awkward position here. Normally I would be working with everything much closer to my body. I'm kind of leaning forward and my arms are kind of cantilevered out, so I'm afraid I may not be able to apply the force that I normally would when I'm working a little bit more comfortably and close. We'll just see how it works out. All right, here we go. Start some floating. Why don't you come up and take a look at the video. All right, that should give us some idea on the downward force I'm able to apply when floating. When I'm floating, I don't usually float with super aggressive downward force. My goal primarily is to warm up the fireboard. All right, so next I'll do some fast passing and see if I can get a little bit more pressure. Here we go. Come on up and take a look. There we go. There we go. Okay. All right. So my final little experiment here will be with my thumb sling applied. And we'll see how this goes. All right, here we go. Come on, let's take a look. Actually starting to generate a little bit of smoke. Okay, I think that's good enough. Okay, well look at that. You see that? I was actually able to get a little bit of smoke and some good black dust with my spindle and that ash fireboard. I didn't expect that. All right, so what we'll do now is I'll go examine the footage and do some eyeball averaging and then multiply by 2 and get some idea of excuse me, the downward force I was applying while floating, fast passing, and using my thumb thing. I'm a little bit out of breath, you can tell. All right, so in video time, I'll be back in just a few seconds, but in reality, it'll probably be tomorrow or the next day. Hang tight. Well, it's been 4 days. I got distracted, but I finally had a chance to sit down and look at the footage from our little experiment the other day. And I did some eyeball averaging and I multiplied by a factor of 2, and I have some data to share. And I wrote it down so I wouldn't forget it. I apologize for using some notes. But when I was floating as energetically as I can sustain, I was getting about 3.5 to 4 pounds of downward force. When I was fast passing, again, as energetically as I can sustain on a regular basis, I was getting about 7 to 8 pounds of downward force, a factor of about 2 increase. And when I was using my Osage orange thumb sling, I was getting about 13 to 15 pounds of downward force. Again, yet another factor of 2 increase in downward force. Now remember, I was working in a little bit of an awkward position, so the absolute pressure values might need to be increased by 10 or 15%. That's just a wild guess, but the relative values are no doubt accurate. So this device is a real force multiplier and has been a real game changer for me. I'm able to create hand drill embers much more reliably and efficiently than ever before. And if you're inspired to do so, I encourage you to give it a try and see if a device such as this can be as helpful to you as it has been to me. All right, let's give it a try. Got a goldenrod spindle on a seasoned white ash fireboard. Let's see what we can do. Smoke. Ember on. You really got to give it all you got to do it with ash. You see it glowing? This may be a first. It's certainly a first for me. I'm a little out of breath, I'm sorry. But I haven't seen ash used as a footboard before using any method of hand drilling. So I'm really kind of excited about this. My little Osage orange thumb sling has really proven quite useful. Goldenrod on seasoned white ash. Worked great. Have a good evening.